hello to this AI Academy today. For those of you who are attending for the first time, the AI Academy is an info series, takes place with nice irregularity, but scheduled every 2 months. My name is Anna. I have the pleasure of moderating today. I work for hessian.AI here. So we are a research and innovation center located, surprise, in the state of Hessen. And at hessian.AI, we are doing research on artificial intelligence, but also try to translate these research into tangible innovations. And that's why we established this AI Academy to facilitate the active exchange between science and application. So we always invite one speaker from the research side and one speaker from the business side. You can expect 1 hour of impulse talk and 15 minutes of Q&A session in the end. And yeah, we always feature a current AI topic that is somehow at the interface between science and application. And today we have the focus on the topic of retrieval-augmented generation, shortly RAG. So a technology that enhances large language models, LLMs, by integrating information retrieval, and thereby also helps to overcome some of the model's key limitations, such as hallucinations, outdated or static knowledge, and especially a lack of access to private company data. So RAG essentially enables companies to chat their internal knowledge base, which makes it a really valuable business application. And it's not entirely new. So RAG has been formally introduced in 2020 in a paper. Technology is around for 5 years by now. But we see that major challenges still remain that prevent RAG from really realizing its full potentials. Problems such as retrieval efficiency, source quality, also the integration of structured and unstructured data sources. So that's why we called today's session Advanced RAG, to take a look at where we stand, but also where the journey might go. And I would like to welcome our 2 speakers for today. So Christopher Tauchmann is one of them. Maybe you can wave into the camera.
Yeah,
so
that's me.
That's me, yeah. So you are our speaker for the science part. And we have Marcel Rosiak with us. Hi, Marcel.
Hi, hello.
He is our speaker from the application side. And thanks for being here, for preparing. And we do have a small welcome ritual at the AI Academy. So we ask our speakers to bring a personal item to introduce themselves and that they associate with their work. So will you tell us what you have dug up? Maybe Chris, you can start.
Yeah, sure, I can start. I will, sorry. Stop this because nobody can see it. I have brought a cuddly toy from my daughter, which I like and which reminds me of the hundreds of questions she asks every day and which I mostly really keenly answer because she's interested in a lot of things. And I like that, as doing research is also very relevant here. So yeah, that's for her and from her. Okay.
Cool, thank you. And could you tell us a
welcome.
little bit more about your work? So you work at the TU Darmstadt. Actually, we are colleagues.
Yeah.
And maybe a little bit about your focus of your research area.
Yeah, so I'm mostly focusing on post-training large language models, meaning a model that is pre-trained and is adapted to either fine-tuned to some specific tasks, or at the moment I'm very much interested in reasoning models, so adapting a model to produce reasoning chains, which many probably saw in ChatGPT or other large models that give you more insight on the one hand and also make the models better mostly. Yeah.
And Marcel, you what have you found while searching in your?
Yeah, there's a little present I want to also give hessian.AI.
Oh wow!
Later, I think next week at the development sprint at the PyCon, we can hand over that because we want to say thank you for the support with the GRAG project and like what we have set up right now. So yeah, that's what I have brought in today. So yeah.
Thanks very much. I wouldn't have expected present. Yeah, thanks to you for preparing. And can you tell us a little bit more about your company and also your role in the company?
Yeah, at this moment, I'm in the AI business development space at embraceableAI, where we focus on like creating digital workforces. Especially my team is leading like the knowledge representation part, how you can model like data and retrieve it in the best and most reliable way. And yeah, before that, we have developed like an own model suite based on like other base models that are specifically like specialized for the retrieval augmented part. What I want also to show like what would be like needed to fine tune like models or like specific part of a RAG systems to really improve the reliability of them.
Okay, so thanks for the intro. I will spare you with more rituals and would suggest to, Chris, you can share your screen and Zoom stage is yours.
Yeah,
For the
I will
next
share
half
my
an hour.
screen. Great. Can everybody see my screen, my slide?
Yes. Yes.
Great. Okay, so welcome. Today I'm going to tell you about retrieval augmented generation. I'm trying to span a bit from foundations to some specific advancements and also applications such as evaluations and applications in the real world. My outline is that I will first go over how it works, then I will detail a bit the retrieval techniques that exist, and also then dive into advanced retrieval augmented generation methods, where we have reasoning-driven retrieval, where we have domain-specific fine-tuning that is very relevant for several sectors nowadays, I would say. We have multimodal RAG, and then I'm going to go a bit into detail on evaluation and benchmarking, some real-world applications. And I'm going to close the talk with the conclusion and some future directions. And please note that this is just a selection. For the sake of brevity, I just focused on some interesting aspects here. So generally, the retrieval augmented generation paradigm combines large language models with external knowledge, where the aim is to retrieve relevant documents and then generate relevant answers based on them. And the goal is to boost accuracy and also have real-time knowledge access, and so to reduce hallucinations. So many so-called hallucinations, so models just producing sometimes random output, is due to the fact that they don't know what's going on and just produce whatever is in the next prediction space. And as we have access to real-time and factual knowledge, this can be mitigated by a large amount. So let's look at the retrieval augmented generation pipeline to get an overview here. And this is a very basic pipeline that can be extended at several parts, but usually you have a user that asks a question on a document, and then you have a vector database that stores the texts that have been vectorized, and a retriever that locates the most relevant documents, and a generator that generates the responses. And so several components here can be advanced and changed and everything. And the retriever is one of them. And there was a change early on from sparse retrieval, meaning mostly term frequency based methods. So how often does a term occur in a document, and based on keyword matching those then extracted, toward a now prominent dense retrieval, meaning we have large trained embedding models. Typically, it's just language models trained with a sort of different objective than the GPT models or so on. So they predict next tokens, whereas these embedding models for retrieval are trained on similarity of words. And one advancement here is hybrid retrieval that combined both techniques and produced significantly better output and also semantic matches. So now let's dive into some more advanced methods. One method here is re-ranking that is very frequently used. So first we have a retrieval component that identifies candidate documents, and then we have another encoder component, meaning another smallish transformer block or so that scores these together and then produces a better output for the relevance with regard to the query. And there are, for example, late interaction models such as Colbert that make this scalable, so that match these components only at a very late stage. We have multilingual and multimodal models by now, which I will detail in somewhat more multimodal focus later on, and also multilingual models that transport the RAG systems to include several languages. And we have also caching methods, meaning speed up methods that rely on caching, meaning storing key and value vectors, for example, to produce the output quicker and to enable some other fancy methods that you can produce on top of them. So one very important thing is domain-specific fine-tuning. And there is, on the one hand, fine-tuning that improves performances in niche domains, meaning, for example, a healthcare application that is very reliant on those types of data can be fine-tuned for this, where you have to curate a domain-specific corpus to adapt the retriever and or the generator. So you can adapt and train the whole pipeline, which is typically what people do. And you would evaluate this with domain-specific benchmarks. There is also early work from, I believe, 2021 that fine-tuned the whole retrieval system towards the application, basically to make them better retrievals. And there is a bunch of literature on retrieval-augmented language models, they called it then, which is also very relevant here. In multimodal RAG, we aim to retrieve beyond text, and this has taken up track in the last years, in the last 1 or 2 years, where there is one very prominent model that is the Coley-Pali model, which is a combination of 2 models, and basically instead of just relying on OCR here to recognize the text, it uses a vision language model encoder to identify the text and then produce the output on that. And of course, there are many more applications that don't really use PDFs, but then you can specifically ask questions to pictures, to tables, diagrams, charts. So there's, I believe, much coming there. The evaluation and benchmarks focus on obvious metrics such as accuracy, obviously. So how well is the answer grounded in the corpus, but there is also faithfulness, which is a metric to evaluate how true is the answer to the facts that we provided, and also how relevant is it. So does it directly answer the question? There is a large body of work on LLMs use as evaluators, not only in retrieval, but generally in language modeling. For example, it's a very often used paradigm to use GPT-4 as a judge. Then there are also frameworks that have been developed specifically for standardized evaluation. One of those is RAGAS. And there are common evaluation benchmarks that pop up again and again. And one is an early benchmark for knowledge-intensive language modeling tasks by Petroni in 2021. And these are the people that also wrote the initial retrieval-augmented generation paper. There's also the natural questions corpus, and all of these have in common that they focus on real-world data and also open domain data, so to make it generalizable. Now, to look at some real-world use cases, we see that retrieval-augmented generation is often used in enterprise and specifically in support use cases. So QA chatbots that provide instant answers where they use manuals, policy documents, knowledge bases. Like, I believe, for example, telecom is one company that uses these things. So generally, every chatbot that produces answers reliant on internal documentation uses some sort of retrieval-augmented generation. I believe DHL is one of those too, which have a, I would say, simple version of this implemented. Then there is healthcare, where there is more and more coming up here, where you have clinical assistants that retrieve patient notes or guidelines and treatment histories. So there is at least one startup I know of that is focusing on these areas. And there is education and tech, where you have tutoring assistants and education that explain complex topics. And one very interesting and very large application is coding co-pilots that can retrieve documentation from your entire code base, for example. So there's for example, Cursor, which many of you might know, or other programs that have instant access to all of your code. And now to come to the conclusion and future directions, we saw that RAG enhances large language modeling capabilities by grounding responses in real-world data, and it can reduce hallucinations and improve factual accuracy. And as that, it's becoming a cornerstone of scalable and trustworthy AI. And looking ahead, we can see that multimodality is enhanced and integrated more and more. And we see deeper reasoning and retrieval synergies here. And I am now already at the end of my talk. So these are the references. And we have, I believe, time now for questions if anybody wants to ask a question. Thank you.
Thank you, Chris. Yeah, we can maybe turn it around a little bit. So we actually planned the Q&A in the end, but might make sense that you have some burning questions right now that you can maybe write into the chat, because we are a bit of a bigger group. Then I can read them out aloud. So we have one question that is, does ChatGPT use RAG as well when providing documents?
Yeah, I mean, I personally didn't use ChatGPT for providing. I mean, I believe ChatGPT doesn't use it because it just fits everything in the context, right? And so you have a limit of what you can input, but tools such as Perplexity, if people know it, or u.com, they use RAG specifically because you can upload very large documents. On what point onwards is it reasonable? Yeah, I'm just reading the questions here too.
Yeah, maybe the follow-up question is, from what point onwards is it reasonable to use RAG, e.g. number of documents?
I mean, I believe it depends. if you don't want to read it, then use GRAG. So I would say if you have a document collection of 100 documents, it's probably reasonable to use it. And if it's very large, it makes sense. It might make sense to fine tune a model. So if you have, let's say, gigabytes maybe, or even more.
And
we have a question.
Yeah, sure. You can also ask it
So
like
when I have
directly.
a very large amount of data, so what should be a good strategy for fine tuning?
Well, I would say first start with some parameter efficient fine tuning methods to see how it goes. So there's, for example, LoRa or other methods that's only you train a bunch of parameters and not all of them. And if that works well, then go on.
Yeah, so you mean that a somehow like fine tune, not on the question answering, but the base model, right? Maybe about embedding model, or maybe the generative model for this.
Exactly. If you talk about fine tuning, you would typically fine tune the underlying language model. Yeah.
Okay, thanks.
There's one more question in the chat from Michael. So how much are hallucinations reduced based on your real tasks?
I mean, it's difficult to quantize this here without having some detailed knowledge on tasks or also evaluations. But I would say quite a lot if you have a good retriever. And it also depends on the base model you use. For example, if you use a very large model, then it's probably less than if you use a small model. But typically what you want to do using GRAG, you want to have a smaller model that you can fit on some sort of, I don't know, maybe not a consumer GPU, but a smaller one, and then use the retrieval component to get the good answers. And then I would say it's quite a lot. Yeah. Maybe. There's quite a lot quantization. I can't do much more.
Yeah, maybe I can hop in on that question.
Yeah, exactly. You have some experience, right?
What we have developed was before like a chatbot solution to like give consulting on technical products, and there you have like many different like number-based values that you need to really get right. And before we have fine-tuned the chat completion model, like for the final answer, we had a success rate of like 75 when we check for like these specific metrics. And when we have fine-tuned it, we get to like 93% correctness. So there are sometimes difficulties with like numerical representations because the probability of like the next number that follows like a comma or something like that is a little bit harder to understand or get right by the language model. And you can really improve on that side for sure.
So thanks for the detailing. There's one more question from Christina. You mentioned if you have a good retriever, you can elaborate on that. Which ones would you consider good? Which ones bad? So it's about the retriever.
So, I mean, for a baseline, I would say a good embedding model. You have a good embedding model and you have a good scoring method. So scoring method meaning retrieving the top 10 relevant documents using a fast method such as FASS, which is the Facebook and search and vector database, and then have a good model for your tasks. Meaning for multilingual, really find a good multilingual embedding model that you want to use to retrieve the documents.
Yes, you got a thumbs up, so I think.
Yeah. So that I can say quickly to the text chunking, and maybe then we move on.
Yeah.
Yeah,
Makes
that's
sense.
text. Yeah, it could be daunting. So I would say one that always works well is the character-based punctuation back and forth. I'm not entirely sure how it's called now. And have chunks that fit on your task. So size-wise, I would say go with 1 or 2 paragraphs and then move up. And LLMs that are particularly useful, I would say the small llama versions are really helpful because they still produce kind of meaningful output, letting you know that everything's kind of all right, even if they don't know. So yeah, maybe we move on and do questions afterwards.
Yeah, I would suggest to Marcel, maybe jump into your presentation, and then we'll have a few additional questions in the end if yours hasn't been answered yet. So Marcel.
Yeah, one moment. Just have to get this right. Okay, yeah. So today we want to talk about reliable RAG system, and we will show a possible way of doing that by the separation of search methods. What do I mean by that? So we have, in the most cases, a database where we have all this data stored. For this example, we have used like an e-commerce related use case. For example, like a shop application where you want to develop application form. And what we do here, we're setting up two different things. So one thing is a lookup collection, because like natural language is kind of fuzzy. And when you have, for example, like a question to a specific category in your shop, there are many different synonyms for that that could like be inputted by the user. And because of that, like a normal fuzzy search or keyword search will not work as expected. And you need to set up these things additionally to really get like the nuances of like natural language requests. And for all of these like kind of different data entities, like products, brands, categories, types, you will set up these lookup collections. And on the other side, you will like have the normal part where you have like the product chunks or like the product description chunks. And you will also store the metadata inside there, because you maybe need that as an additional filter. For example, you're like ask for a specific price range or like for a specific brand. And maybe there are other metadata that is interesting, and you should definitely store that additionally, because that could also help later in the retrieval part when you re-rank the results. And when you have like basically mirrored all your data from the database into the vector database, into these two different kind of like usage clusters, then you can start to build like a RAG pipeline. And a RAG pipeline could look something like this. So in the first place, you have the user, you have your RAG system, and you have your database and your vector database in our example. And what we can do by that is like when we get a query like, I need a gimbal for the Sony FX6 that like can hold 4 kilograms. Then you basically have two LLM calls where you analyze this query, because you have to decide what exactly we will do with it and what you want to do with it, and like how you structure your search queries. And with that, these are like two parts that happens concurrently. So you use the request to the entity extraction at the same time as you like do the request to the router. And the entity extraction could look like something like this, like a JSON structured output, where you extract like from the user query, which categories like the user asked for, which reference products the user is mentioning, and what capabilities was mentioning. And with that, you can like have for sure like the first query where you embed these kind of like extracted entities. And then you check in these lookup collections I have shown before, which could be applicable matches of that. You can do that like only by vector search, but you can also combine it in a hybrid search way in terms of like a fuzzy search approach, or like yeah, you can combine different search methods here to really find the most suitable like match in your database to that. And if you don't get like over a specific threshold, then you will simply like stop the request and say, for example, when you are selling video equipment and he is asking for a fridge, then you simply say, okay, we don't have this in our shop, so we can't help you with that. So that could be one part where you like even get in that stage out of like the user conversation. And on the router side, we have at least 3 different like routes we can like access or like explore. And this is a composite route. For example, when we search in the database and also in the vector DB. But there's also a way where we only have to search inside of the normal database or only search inside of the vector database. There could be subroutes in each of them, because it could be that you want to like tackle some really specific things here, and maybe like structured has a subroute that you can organize. But for the simplicity of explaining this, I think the 3 routes are enough. And here we use like the matches from the vector database lookup collections to search in the database. And from the database, we get a first candidate list. That could be something like for example, specific accessories for a product. And we have verified from the database that these products are really like compatible. And with that candidate list, we can search now for the capabilities that are asked inside of the vector database, where we have stored the product chunks. And when we have searched for that, we have, again, there like a similarity threshold where we say, okay, above a specific score, we will like count a candidate as a valid candidate, we could say. And with this filtered list of candidates, we do a re-ranking step. That could be something like this, like we have an ordered list, like based on the embedding score from the vector database, that we then can like re-evaluate or re-rank in terms of the search query, and maybe some additional things you can even add to that. So the embedding search works like you compare 2 text embeddings or representations between each other, but a re-ranker can even work with like structured data. So when you have compared before the query and like the product description chunk, then in the next step, the re-ranker can even work with like structured JSON, and there's more data that they can use to really readjust the sorting. So in the end, it could be that at first you had product 1, 2, 3 in that order. And after you have sorted it by the relevance, you have then product 2, 1, 4 in the same order in terms of the relevance to the query. And at the end, you have like the generation part where you like input this context data into like a language model. And you have, in most cases, a predefined answer structure, how the model should respond. In many cases, you can only do that by prompt engineering. But if it is really like critical to get like the data or like the context right, or like also providing sources like from which chunk you have that information, then it could make sense to even fine tune that. And this whole process with a database takes like 5 to 7 seconds. That is a little bit long compared to like normal applications that, you know, when you just ask ChatGPT anything without context. But it is a reasonable amount of time to wait for like a really structured and thoughtful answer. When you replace the database with a graph, you can reduce that, reduce the time until the user gets the final answer. And to maybe show the people that have never seen like a graph could be modeled or visualized, you see here at the upper right, that's like the light blue color, like circles are products, for example. And then, for example, we have a dark blue color that are the categories. And these products are linked together by like relationships that you can model to like store additional information about like how they like interact with each other, or what is the specific relationship like called, or even if this relationship has like some properties you can store. And in one of these nodes, for example, you can store everything like you would expect in a normal database. You see in the down left corner what you can store there. We could also store like image URLs there, but there are ways to also do that in a multimodal way. So a base 64 encoding or something like that from an image would be also possible. But yeah, that is like a more specific case where we maybe can look into in the next year. Yeah, and when you think about it, in the graph, you can like organize data of like different databases or sources. So for example, from your shop system, your ERP system, your CRM system, and like the method to really query all this data is more or less every time the same. So if you, for example, want to search for all the gimbals you have in your store, then you simply look into, go into like the query, like give me all the nodes that are connected to gimbals that are product nodes. So for example, these ones. Then another example, when you want to get all the gimbals from DJI, that is a brand, then you simply like connect these two in the query and search for all the like products that are connected to both nodes. And from that side, you can like further like model complex search queries that would mean like multiple joins in normal SQL tables or multiple API requests in an API that your store or like your ERP system offers. And then we also have like simple queries where you ask for specific products or like comparing two products together. And here we have an example that we have like a specific request for a category and a specific reference product. So the Sony FX6 is a camera. And then in the first step, what we have seen on the left side in like orange yellow surrounded, you get like the first candidates that are like suitable for that kind of request. And now in the second step, we look into the product descriptions, so the product chunks, if we can find like the reference that this gimbal can hold more than 4 kilogram. And with that example, it is a little bit better understandable, like why you do that in 2 steps, because like only like the graph or like the database cannot give you the full answer if you not have fully modeled or like separated all this like additional properties from the product description as like structured text. And yeah, that enables like an easy way to really like use your unstructured data, but first you always check if like the relationship is met that you want to see. And in the next step, I would like to go into the topic of like the different parts of like the RAG system or GRAG system. And there we have, for example, like the embedding part where we can improve our Retrieval-Augmented Generation system. And that works like the following. You have the context, you have the chunks of, for example, the product descriptions. And from each chunk, you will like instruct a model to come up with a question that could be answered by this chunk. And in the next step, you would, together with the chunk, ask the question to a language model to answer that question, and only like provide this simple like one chunk to really answer that question. And with that, you can set up connections like positives and negatives. For example, when this context here is from one product description and you have two chunks, and you have like a direct connection between the question and the chunk that what it was generated on, then you can set up an additional connection to the chunk of the same product, but from a different part of the description. And with that, you have like a positive example that can really answer the question, and a negative example that is quite near because it is still the same product, but not really relevant to answer that question. And that enables you to set up like a first like training data set where you can train a model on like the combination of like the question, for example, and these both chunks as one positive, one negative. Or you could also use like the answer as the query here to even get more training data, because it is not always a good idea only to train on questions. You should also train on like Aussagen, statements, yeah, or like the answers, because it is quite important to get both sides to really like shift the model to a stage where it really understands like the fine nuances between like chunk 1 and chunk 2, even if it is about the same product, for example. Then the next topic would be the re-ranker. The re-ranker has more or less the same training data structure, but we need additional scores to between the connection of the question or answer, like basically the query, and like the provided chunks in the training data. So this could be done by using an embedding model and see what score comes out for like chunk 1 and chunk 2, and then maybe improve like chunk 1 at like plus 5% or something like that, that you really can steer the score to the direction you want. Or you could also like use LLM as a judge, more or less, to generate a score for each specific chunk. That could be also possible. But in the end, it's important to get like really like chunks that are near each other from the semantic meaning, but still have a difference. So you should really ensure that these negative chunks really don't answer the question. That is really important on that side. Then we have the extraction part, and a graph makes this task way easier than a normal database, because you can simply retrieve all node combinations that you could gather. And for that example, where we have developed that in a research project at the Teltech web store, we had 25,000 products. And when you export all of these combinations with like, this is an accessory for that camera and so on, and what kind of like top, mid, and subcategories you have, you get to like 1.6 million combinations. And you can simply like get that out of the graph. And that would be kind of a headache to do with a normal database. And with that information, you can for sure can structure like the structured output that you would need for the entity extraction. And you can set up some kind of like templates in the first place to structure queries that a user could ask. but you should definitely add like more advanced like generation pipelines to get a really diverse set of like question structures. So it should not always be the same, because then you makes it quite easy that the model will understand where the category stands and where the reference product is stated. That side, you should definitely use another LLM to restructure that sentences, and maybe even go further in terms of like yeah, how big the questions would be, or add like additional information, but that is maybe not that yeah, important. Like when they ask for a use case, for example, you can first input like that in front of like the normal question to get a little bit more noisy data. Yeah. Yeah. And for the router, you basically need the same sample queries. Like I need a gimbal for the Sony FX6. You can use the exact same input data for that. But in this case, you will like train the model or fine tune the model better to like reason about like which route it should take, and then also instruct it to give you a structured output. For example, like when I have this query, I need a gimbal for the Sony FX6, and that is a composite query, because we have to first check in the knowledge graph which like products are connected to the Sony FX6 before we can query for a specific capability. On the other side, there could be just a question, I need a gimbal, and we can directly answer that by the graph. And because it is just like a request from like one connection, you don't have to really look into the unstructured data to understand if this is a good, or like, is this product, if the products that you received are a good fit. They are definitely applicable and suitable for the request, because you also don't have more information than like, I need a gimbal. And on the other side, we could have like a user query where we just need like a specific name of the product to really search inside of their product description. For example, I just want to know what sensor does the Sony FX6 has. Then you can directly go into the vector database and search in the appropriate product description chunks to really get like the insight of what sensor the Sony FX6 has. And on the last part, we have like the predefined answer structure, like the chat completion that works with the context. And you basically put in the original user query, then also the context, and then you want like a specific structure of the like result, or like the generated text from the LLM. And for example, in our case, that were bullet points that we wanted to get a quick like overview of like which product offers which features. It could be also that someone is requesting like a table comparison of two products, or it could be any format that you can handle with Markdown, I think. Or maybe, yeah, there are also other ideas to implement like executable code or something like that. And yeah, for that case, you reach a really reasonable like result quality with prompt engineering, but it could be beneficial when you, for example, as mentioned before, working with like technical metrics or something like that. Then maybe it's a good idea to fine tune the model, because then you like directly connect the input context with the result, and then it follows better the provided context or the information in the context to really give that kind of like accuracy in like number recall. Yeah. Okay. And then maybe just as a little inspiration, what you can do, for example, with a graph, when you include all the different data sources, you can input like the customer history, what he has seen in this session, like he is right now in the online shop and seeing through like different products, or what he have bought before. You can see like maybe a customer type, what preferences a typical customer has of this specific type, in terms of like which brands he chooses, or which accessory for the most time he orders. Then we have maybe additional context from the initial product. So for example, the Sony FX6 we have request for, the camera. Maybe there are important features we need to mention that like are important to answer this question. And then we have like maybe suitable accessories with the relevant features. And as we have said before, we had the compatibility check to really like understand that these products that are in the context are really suitable for the request. And then we let the model decide like which one is really the best one to show to the customer. And on the right side, we see a little screen recording of the application we have developed. And here you can simply see you get like additional product cards. So you can also like really provide a value just by a better UI that helps the user to simply use the kind of data access he has now. And yeah, you can just follow up the question, compare two products, and see what would be the best fit for you and your setup or situation. And that was basically the end of my presentation. And if you have a complex portfolio or a difficult use case, we can definitely chat. And I would be happy to share even more insights about like the training of large language model, embedding models, or like simple web applications. Yeah, thank you.
Yeah, thank you as well, Marcel, for preparing, for sharing. That's always work, so we appreciate that, and has been really nice visualization of complex tasks. So yeah, you can write your questions in the chat, ask them directly. We still have a remaining question from Jonathan. Maybe I'll start with that. Do you have any recommendations on a machine that is powerful enough to run private RAGs to comply with Datenschutz, data privacy? If
in a business setup or like on a private way?
Actually, if I may say, in a business setup, that would be. Thank you.
What I think what is the most interesting development right now is Project Digits from NVIDIA, because you can also run quite big models, but I think it will be published in May this year. That has like a unified RAM, and then you can simply host also like really big models like Llama 70B or something like that. And with that setup, I think you can definitely have a good like starting point to set up a local RAG system or private RAG system that is fully under your control.
Thank you.
There is a question coming from Juan. Do you have any insights or ideas on automatic knowledge graph creation, the different philosophies and so on? For example, having or not a predefined ontology, generative, based, and so on.
Yeah. So
the step before, actually.
Yeah. There are interesting like projects, like you have maybe seen the GenAI graph builder from Neo4j. That is like a user interface where you can input documents, and then you can like give it a hint of what your ontologies could look like, but more or less the LLM decides like how it will set up the ontologies and will fully structure your graph by itself. That is kind of interesting. And there's another project in the USA that is named YHow AI, where you have like a graph data studio where you basically manage all of these connections. And I think it is called Graph Table Studio. So there are two different open source projects where you can input like any OpenAI compatible LLM, and then you input like your structured or unstructured data together, and can even like analyze it and add additional metadata to it. So I think these two projects are really interesting. We are also looking into directions of making that as universally as possible, but in many like use cases, an ontology is needed that you define it before to really get the most out of the graph you can get. Yeah.
Thank you. Any more questions from the audience?
Yeah, I will just type it here.
Oh, okay, so also maybe a question from my side. How did you see that? Did you see that integrating knowledge graphs also brought with it some downsides, because you always have a trade-off basically. When you gain something, you lose something as well.
Yeah. So yeah, there are more downsides. You have like another data source you have to manage. You have to synchronize to all the other like data or information sources. So there is like a management overhead to do that, or operations overhead to do that. But in the end, you benefit more from like this unified structure, and you can simply like add additional sources from time to time to really conquer all the different like use cases that are possible when you have access to all of the data that is connected. And that could be on like the analytics side, where you analyze this data and see where there are like possible changes you can make in your business. For example, we have provided Sony an analytics dashboard where they can simply see like which products get often bought together, or like are bought together but in different orders from the same customer. And with that information, they can set up campaigns with the marketing team to set up bundles, and with that, like the amount of the total cart increases. So I think, yeah, it's quite much work to do to get it right in the first place, and also if you do that the first time. But like the benefits definitely are bigger than that. Yeah.
And maybe one last question coming again from Juan, a little bit similar to the previous question. So any interesting direction for the creation of graph queries within the pipeline, static or also automatically created by an LLM?
I think the pipeline is meant by like the RAG system, right? Okay, yeah. We have tried to train a model to do proper Cypher queries, like that is like basically like SQL queries, but a little bit different, especially for like Neo4j or graphs in general. And we found that it is kind of hard to get this right, because like this query language is very, very sensitive to like small like changes in how you set up these queries. And we don't have seen like a really reliable system that can do that. And because of that, we rely on like the router and the extraction part that I have shown. Then you can use like predefined templates where you can like set up these queries one like part by part. Like it depends on which entities you extract and which root you have identified, and then the query will build up, basically. So for building a system like that, you will definitely need like an understanding of how to like create these different parts of the query together and to use it in a template-like way. I hope that has answered the question. Yeah. No problem.
Okay, then I would say we end this Q&A session here. If you have further burning questions, I think you can also reach out to Marcel and Chris after the event directly. And yeah, I've gotten some questions about the video recording, so we'll be posting it on our YouTube channel, the hessian.AI YouTube channel, and then you go to the AI Academy and can find it there. And yeah, I have 2 small announcements to make on our own behalf. So we'll have an event upcoming next week in Darmstadt. We will be co-hosting so-called development sprints at the PyCon conference, so a big Python developer conference in Darmstadt on the 22nd of April. So we'll have a really hands-on coding session all day long, 10 open source projects sprinting. Marcel provides one of them. So yeah, you can maybe build on what we learned today there. I'll just post a link in the chat. Would hope to see some of you there. Like that. Yeah, and if you like the format today, you can also register for our AI Academy newsletter. Then we keep you updated about the upcoming topics. Also a link in the chat. And yeah, that was it for today. So thank you very much for attending and for sharing, being here, your interest, appreciate it. And yeah, goodbye.
Thanks, goodbye. Bye-bye.
Bye-bye.
Thank you. Bye.
Bye, thanks.